what does that number that's in with the x, how did that transform our function? When you put a number in yesterday, what did it do? Go ahead, Pete. Move it left and right, okay? Yeah, Tyler, is that what you're going to say too? Okay. Yeah, moved it left and right, which again should hopefully make sense, right? Because it's in with the x. X is in charge of going left and right. H is going to shift things left or right. All right, now you'll notice here I have a minus h. So if I subtract a positive number, right? So if I have x minus 3 or x minus 4, right? If I'm subtracting a positive number, if h is greater than 0, which way are we shifting it? So if I have like minus 2 here, that would be shifted which direction? Right. 2, right? And so when we have a positive number here for h that we are subtracting, okay, we shift right. Okay, h units. And so then it stands to reason, how are we going to shift it left? We will want h to be what? Less than 0 or negative, exactly right. Which makes it then, if h is negative, you'd be subtracting a negative. And what's the same thing as subtracting a negative? Adding a positive. So when you see x plus 2, that's really left 2 because it's subtracting a negative there. Okay. So h less than 0, shift left, again, h units. Okay? So that's what h did, and then we move on to our parameter for a, our a parameter there. Okay? And what did our a parameter, what did it do? How did it affect our graph yesterday, if you remember? If you put a number in front of the function and you multiply, right, it's a times f of x.
We're going to stretch it?
Okay, it stretches it. Which direction, you remember?
Left and right.
So
wait, I know, actually you would go up or down.
Yeah, it's the vertical stretch, yeah. If you want to think about it this way, again, when you're multiplying a number times your function, the function is like the y value. So a times the y value would stretch it up and down. Okay? How do we make it actually stretch? A would need to be what? To make the graph stretch and get bigger, a would need to be positive and bigger than what number? 1. Got to be bigger than 1. Okay? Vertical stretch. By A. Okay. So yeah, if we multiplied by a decimal, like you said, Bobby, like 0.2 or 0.5, that wouldn't be a vertical stretch. That would be a vertical what?
Change.
It would be a change. How?
Transition, right?
Not transition, no. A stretch, your graph gets bigger if a is greater than 1. How do you make the graph smaller? A shrink, yeah. So a has to be between 0. In fact, I should put absolute values around this a too. Okay, so if the absolute value of a is between 0 and 1, that's a vertical shrink. Okay, vertical shrink. There's one more thing that a could do, right? There's one more thing that a could do. What happens if a was negative? What would that do to the graph? Did anyone get a chance
to
flip it? Yes, it reflects it over the x-axis. Yeah, so if a is less than 0, that's a reflection over x-axis. Okay. So, these 3 transformations are going to be our primary transformations that we'll see for pretty much every function. There's towards the end of this class, like May or so, we'll be looking at trigonometric functions, graphing sine of x and graphing cosine of x. Those are waves. Okay, and then that b shows up here in front of the x. B will be showing up in those. Okay, but we're not going to worry about that right now. So the 3 main transformations are vertical stretch and shrink, reflection of the x-axis, shifting left, right, shifting up and down. Okay, these 3 parameters. We are going to see this every single unit. I'm going to do this every single unit with whatever function we're studying. Okay, in fact, and like tomorrow, or maybe the day after tomorrow, Friday, we'll be looking at absolute value, and I will write this exact thing, but with absolute value instead of just with a generic function. So the sooner you understand that, the easier life will be for you as you go through this class. Okay, we're going to see this again and again. And it doesn't change. K will shift things up and down. H will shift things left and right. A will stretch things. Okay, one last thing I want to show you here, and that's even, odd, and neither. Okay, and we're going to focus on identifying these just by visual inspection. Okay. An even function is symmetric over the y-axis, and I'll draw an example here. Okay. There's an example. Okay, a parabola. A parabola, I should say this particular parabola, f of x equals x squared, okay, is even. Symmetric over the y-axis. Do you guys know what I mean when I say symmetric over the y-axis? What does it mean for it to be symmetric over the y-axis? What happens with this graph and the y-axis there? How is that symmetric? What's the symmetry there? Paige, do you have an idea? Yeah, you can imagine like folding this graph or reflecting it over and it'll perfectly match up, or vice versa here. You can reflect it over and it'll perfectly match up. Yeah, that's a basic idea there. Okay, the y-axis is kind of like your fold line, and it should match up. Okay, that's a symmetry. It was the symmetry we're talking about there. For odd functions, we're looking at rotational symmetry of 180 degrees. Okay, about the origin. Remember, that's the point 0, 0. Okay, so what does that look like? Here's an example of that. Okay. A classic example of an odd function would be like the graph of the cubic function. Okay. It's odd, right? Odd. I could rotate this graph 180 degrees about the origin and it would look the exact same, right? I could take my finger here, put it at the center, rotate 180 degrees, and that looks just the same as my original function, right? So that's an odd function. Okay. If a function is not even, if a function is not odd, then it's neither. Okay, that's just what we say. Okay, not even, not odd. Okay, not every function is even. And here's an example, or odd. So here's an example. But Mr. Way, you just got done saying even functions. An example of an even function is this parabola right here. Why is this parabola not even? Yeah, Tyler? Yeah. There is a line of symmetry here, right? I could draw the line of symmetry in right here, but that line of symmetry is not the y-axis. It's got to reflect over the y-axis. So it does have a line of symmetry right here, okay, but it's not the y-axis. So that's what makes it neither even nor odd. Okay, so your assignment tonight, okay, if you turn the paper over, the original paper that we got, okay, from homework yesterday, I'm just going to have you guys do a few more from that. Okay, so we'll go on to the back. Okay, and on page 32, so this is in section 1-3, page 32. Okay, numbers. All right, brace yourself. Here we go. Ready? 8, 10, and 13. Okay. 13 is where you will be able to identify whether the function is even, odd, or neither. And they give you the graph, so it makes it super convenient to identify. Okay, so that'll take you all of like 3 seconds probably to answer those. All right. And of course, then 2 more functions there for you to transform. And that'll be the homework. Very easy. I can get you a book, or I can also show you. Let's see. Do I have a spare book? I don't have a spare book, but the paper that I gave you today, it's got those on it. I'll get you a book. I'll try and get you a book tomorrow. Okay. Sorry about that.